Before there was a number called zero, there was silence. And into that silence, one man walked, alone, brilliant, defiant, and said, "Nothing is something." What he wrote next would shake the very foundation of human thought and would not be fully understood for over 1,000 years. Stay with me, because by the end of this story, I am going to reveal one staggering fact about Brahmagupta that almost no one talks about, a detail so remarkable, so quietly world-altering, that it will change the way you see mathematics, history, and perhaps even yourself. Do not go anywhere. Welcome, welcome, welcome to Numbers and Narratives by Bless Wright, the channel where numbers are not just cold, lifeless symbols on a page. Here, numbers breathe, they bleed, they fight, they survive, and the people behind them, they are some of the most extraordinary, most overlooked, most underestimated human beings who ever walked this earth. Today's story is one of those stories. A story from the heart of ancient India. A story about a boy born in the dust of Rajasthan. A boy who grew up to stare into the void and name it. A boy who looked at nothing and said, "Here are the rules. Here is how nothing behaves. Here is how you add it, subtract it, multiply it, and divide it." A boy who became the father of zero. If you are new here, welcome to the family. Please subscribe right now, hit that notification bell, and leave a comment below telling me, what is the most mind-blowing fact you have ever learned about mathematics? I read every single comment, and if you are part of our community already, thank you, truly, thank you. Now let us get into the story, and remember when you stay until the very end, because I have saved something extraordinary for you, something that will leave you breathless. Imagine a world without zero, not a world that has forgotten zero, not a world that is confused by zero. A world that has never even imagined zero. A world where the concept of nothing as a number, as a quantity, as something that can be written, calculated, and reasoned about, simply does not exist. That world is not science fiction. That world is not some fantasy. That world is the world that existed before the 7th century. That world is the world before Brahmagupta. Think about what that means for a moment. Think about how you count things. Think about how your phone works. How your bank account functions, how airplanes are navigated, how drugs are dosed in hospitals, how bridges are engineered, how satellites orbit the Earth. Every single one of these things rests, at its very core, on mathematical systems that include zero. And zero, as a fully defined mathematical entity with rules and properties, was given to the world by one man. One extraordinary, brilliant, painfully underappreciated man. A man born in 598 CE, when the ancient kingdom of Rajasthan in what is now northwestern India. A man whose name was Brahmagupta. But before we get to the man, we have to understand the world he was born into. Because Brahmagupta did not appear out of nowhere. He was not a divine accident. He was the product of a civilization, the civilization of ancient India, that had been nurturing mathematical and astronomical thought for centuries. He was born into a tradition of inquiry, of deep intellectual hunger, of a culture that looked at the stars and felt compelled not just to wonder, but to measure. India in the 6th and 7th centuries was a place of extraordinary intellectual ferment. The Gupta Empire, which had dominated northern India for nearly 200 years, had ushered in what historians call the Golden Age of India, a period of towering achievement in literature, art, philosophy, astronomy, and mathematics. The Gupta period produced Aryabhata, much of the genius who calculated the approximation of pi to 4 decimal places, and who suggested, with breathtaking boldness, that the Earth rotates on its own axis. The Gupta period produced Varahamihira, the polymath who wrote about planetary motion, astrology, and mathematics with astonishing sophistication. And it was into this inheritance, this river of extraordinary intellectual tradition, that Brahmagupta was born. His father's name was Jisnugupta, and the family was deeply rooted in the Brahmin scholarly tradition. From the earliest days of his life, Brahmagupta was immersed in learning, Sanskrit, Vedic recitation, philosophy, and mathematics. Always mathematics. There is something hauntingly beautiful about imagining young Brahmagupta, a dark-eyed boy in a land of blazing sun and ancient dust, sitting with a stylus and a clay tablet, working through calculations that no one around him had ever attempted before. Well, he grew up in the city of Bhilamala, today known as Bhinmal, in the Gurjara region of what is now the state of Rajasthan. Bhilamala was not a backwater. It was a thriving, sophisticated urban center, a hub of trade and learning where scholars gathered, debated, and competed. And from an early age, it was clear that Brahmagupta was not just another student. He was something else entirely. He was the kind of mind that appears only once in a very long time. By the time he was 30 years old, so he had already done something that would have been astonishing for a man twice his age. He had written a book. Not just any book, a book that would become one of the most important mathematical texts in the history of human civilization. The year was 628 CE. Brahmagupta was exactly 30 years old, and the book he wrote was called the Brahmasfuta Siddhanta, which translates roughly as the opening of the universe, or the correctly established doctrine of Brahma. Say that name slowly. Question Brahmasfuta Siddhanta. Let it sit on your tongue for a moment, because that name carries within it a kind of weight that most words will never know. 25 chapters, written entirely in verse, because in ancient India, important knowledge was encoded in verse so it could be memorized, transmitted, preserved. And within those 25 chapters, woven between astronomy and algebra, and geometry and arithmetic, were ideas that would reshape the entire trajectory of human intellectual history. But let us be honest about something. Before Brahmagupta, zero had existed in India, in a sense. The concept of emptiness, of shunyata, had philosophical and even numerical roots going back centuries. The Sanskrit word shunya, meaning void or empty, had been used in mathematical context before Brahmagupta. Aryabhata had used a place value system that implied the existence of zero as a positional placeholder. But here is the crucial difference, and this is the difference that matters enormously. No one before Brahmagupta had ever defined zero as a number in its own right, with its own arithmetic rules. No one had ever asked and answered the question, what happens when you add zero to something? What happens when you subtract zero? What happens when you multiply by zero? And that is where Brahmagupta did something that no one, not Aryabhata, not Euclid, not Archimedes, not the Babylonians, and not the Egyptians, had done before. He sat down, he thought, and he wrote the rules. Close your eyes for a moment and try to appreciate the audacity of that act. The audacity of taking nothing, literally nothing, the concept of absence, the concept of void, and saying this is a number, and not just a number, but a number that obeys specific laws. A number that interacts with other numbers in predictable, definable, calculable ways. In the Brahmasfuta Siddhanta, Brahmagupta wrote, in the elegant, compressed language of Sanskrit verse, something like this: a debt minus zero is a debt. A fortune minus zero is a fortune. Zero minus zero is a zero. A debt subtracted from zero is a fortune. A fortune subtracted from zero is a debt. The product of zero and a debt, or zero and a fortune, is zero. The product of zero multiplied by zero is zero. Read those lines again. Read them slowly. Because what you are reading is not just a mathematical definition. What you are reading is a revolution. What you are reading is one of the most consequential paragraphs ever written in the history of human thought. Brahmagupta was not just defining zero. He was giving zero a personality. He was giving zero a role in the drama of arithmetic. He was making zero a citizen of the number system, with rights, with relationships, with a place at the table. And he did not stop there. Because here is where the story gets even more extraordinary, and even more emotionally devastating if you stop to think about what it means. Brahmagupta also introduced the world to the concept of negative numbers, what he called debts, as opposed to fortunes. Before Brahmagupta, negative numbers were not a formal part of mathematical reasoning in the way we understand them today. The Greeks, for all their mathematical genius, had no concept of negative numbers. The Romans had no concept of negative numbers. But Brahmagupta, with the precision and boldness of a true pioneer, laid out the rules for negative numbers with remarkable clarity. He described what happens when you add a debt to a fortune, what happens when you subtract a larger fortune from a smaller one, what happens when two debts multiply. Think about the emotional reality of what that means. Think about a world where you cannot mathematically express the concept of owing more than you have. A world where the language of mathematics has no word for deficit, no symbol for loss, no way to formally represent the state of being in the red. And then imagine one man in a city in Rajasthan picking up his stylus and changing all of that. Not because someone told him to, not because a king commanded it, but because his mind demanded it. Because the truth of mathematics was pressing against the walls of the existing system, and someone had to be brave enough to break through. Brahmagupta was that someone. Now let us talk about the man himself, because Brahmagupta was not some withdrawn hermit scribbling in a cave. He was a public intellectual, a scholar of enormous standing, a man who operated at the very highest levels of the intellectual world of 7th century India. He eventually became the head of the astronomical observatory at Unjan, one of the most prestigious scientific institutions in the entire ancient world. Unjan was to 7th century India what Alexandria had been to the ancient Mediterranean world. It was the intellectual capital. It was where the best minds gathered. It was where the stars were studied and the numbers were wrestled with, and the boundaries of human knowledge were pushed outward into the dark. And Brahmagupta presided over all of it. Can you imagine the weight of that responsibility? Can you imagine the intellectual fire that must have burned inside this man every single day? Hashana, here he was, at the summit of his civilization's scientific establishment, surrounded by brilliant colleagues in rigorous debate, and yet he kept reaching further. He kept pushing harder. He kept looking at the numbers and asking questions that no one else had thought to ask. His work was not limited to zero and negative numbers, extraordinary as those contributions were. In the Brahmas Siddhanta, Brahmagupta also made profound contributions to algebra, which the ancient Indians called bijaganita, meaning seed arithmetic. He worked on what we now call quadratic equations, and he developed methods for solving them that were genuinely sophisticated. He gave rules for computing the area of a cyclic quadrilateral, a four-sided figure inscribed inside a circle, that became known in the Western mathematical tradition centuries later as Brahmagupta's formula. And it is a formula of breathtaking elegance, a formula that reveals something deep and beautiful about the relationship between geometry and arithmetic. He also worked extensively on what mathematicians today call Pell's equation, a type of indeterminate equation of the form x squared minus n times y squared equals 1. This type of equation is notoriously difficult. European mathematicians would not crack it until the 17th century, a full 1,000 years after Brahmagupta had already developed methods for solving it. 1,000 years. Think about that. Think about what it means that one man in 7th century India was solving problems that the best mathematical minds in Europe would not reach for another millennium. But let us go back to zero. Let us stay with zero for a while longer, because zero is the heart of this story. Zero is the wound at the center of everything. Zero is the thing that makes your chest ache when you truly understand what Brahmagupta did. Here is what I want you to feel, not just understand. Before Brahmagupta defined zero, the number systems of the world were, in a very real sense, incomplete. They could handle counting. They could handle addition and multiplication, but they could not handle absence. They could not handle the space between having something and owing something. They could not handle the idea of a temperature that is neither above freezing nor below it, but exactly at it. They could not handle the moment of stillness between one note of music and the next. They could not handle the precise mathematical boundary between having and not having. And because they could not handle zero, they could not build what we have built. They could not do calculus, which Isaac Newton and Gottfried Leibniz would develop 1,000 years later, and which depends absolutely and fundamentally on the mathematics of zero and infinity. They could not build computers, which operate on a binary system of ones and zeros, a system in which zero is not merely present, but is literally half of everything. They could not navigate to the moon. They could not design a microchip. They could not write the code that runs your phone. All of that traces back to a man in 7th century Rajasthan who looked at nothing and refused to let it remain undefined. I want to talk about the loneliness of that, because there is something profoundly, heartbreakingly lonely about what Brahmagupta did. When you are the first person to articulate something truly new, not a refinement of existing knowledge, but a genuinely new idea, you are, in a very real sense, alone. You are standing at a frontier that no map covers, in a territory where no one can follow you until you show them the way. And Brahmagupta was not just stepping into new territory with his ideas about zero. He was leaping off a cliff into the unknown and building wings on the way down. And he did it in verse. He did it in the beautiful, compressed, rhythmic language of Sanskrit poetry. He took these tremendous, world-altering ideas about zero and negative numbers and algebra and astronomy, and he encoded them in verse, not because it was easy, but because in his culture, verse was the vehicle of permanence. Verse was the form that survived. Verse was the technology of memory. And Brahmagupta, with the clear-eyed practicality of a true genius, understood that an idea that cannot survive is an idea that cannot save the world. So he wrote in verse, and the verse survived, and the ideas survived, and here we are 1400 years later talking about him. Let us talk about what happened next. Well, because the story of Brahmagupta's ideas does not end in Unjan, it does not end in India. It travels, it migrates, it crosses deserts and mountain ranges and civilizational boundaries carried by merchants and scholars and translators, and it arrives in the Islamic world during the great translation movement of the 8th and 9th centuries. When the Abbasid Caliphate in Baghdad embarked on one of the most remarkable intellectual projects in human history, the systematic translation of the world's accumulated knowledge into Arabic. The Brahma-Sphutta Siddhanta was translated into Arabic in the late 8th century under the patronage of the Caliph al-Mansur, who reportedly said, in something close to these words, that he wanted all the wisdom of the world to flow into Baghdad, and flow it did. Indian astronomy and mathematics, when including Brahmagupta's revolutionary ideas about zero, poured into the Arabic intellectual tradition and transformed it. The great Persian mathematician Muhammad ibn Musa al-Khwarizmi, from whose name we get the word algorithm, and from whose book title we get the word algebra, drew directly on Indian mathematical traditions that included Brahmagupta's work. Al-Khwarizmi's treatise on the Hindu numerals, including zero, was what eventually introduced the Indo-Arabic numeral system to Europe. From India to Baghdad, from Baghdad to the scholars of the Islamic world, from the Islamic world to Europe, through the translations made in the great centers of medieval learning in Spain and Sicily, and from Europe to the modern world, to calculus, to computing, to the digital age, to every screen and every satellite and every algorithm that shapes your life today. Brahmagupta set that chain in motion. Brahmagupta lit the first fire in what became an unbroken chain of intellectual illumination, stretching from 7th century Rajasthan to the smartphone in your pocket. Now, I want to take a moment to speak about something that very few people acknowledge, and that is the emotional cost of being a pioneer. Because being first is not always triumphant. Being first is often painful. And Brahmagupta knew pain, intellectual pain at least, because not everyone in his world agreed with him. Not everyone celebrated his ideas. There were debates. There were disputes. There were other scholars who pushed back on his formulations, who challenged his astronomical conclusions, who disputed his mathematical assertions. Brahmagupta, for his part, was not a particularly humble man about his own genius. His writings carry a distinct note of confidence, sometimes tipping into what we might call intellectual combativeness. He criticized Aryabhata, his great predecessor, sharply and at times harshly. He disputed Aryabhata's claim that the Earth rotates on its own axis. Ironically, the one area where Aryabhata was profoundly correct and Brahmagupta was wrong. He also wrote against other astronomers of his time with a directness that sometimes approached contempt. But that is part of the humanity of the man, is it not? He was not a saint. He was not a prophet. He was a human being, brilliant, driven, competitive, and capable of both magnificent insight and significant error. He was the kind of person who could see further than almost anyone alive in his time, and yet still be blind in certain directions. And that is what makes him real. That is what makes him someone you can grieve for and marvel at and feel for, rather than simply admire from an abstract distance. He died in approximately 668 CE. He was around 70 years old. He had spent his entire adult life at the intersection of astronomy and mathematics, pushing the boundaries of both, writing prolifically, thinking ceaselessly, arguing passionately. His second great work, The Khandakadyaka, written in 665 CE, just a few years before his death, was an astronomical handbook of remarkable sophistication, dealing with the calculation of planetary positions, eclipses, and the rising and setting of celestial bodies. When he died, he left behind a body of work that the world would not fully appreciate for centuries. He left behind mathematical truths that would travel farther than he could ever have imagined. He left behind ideas encoded in verse that would outlast kingdoms and empires and civilizations. He left behind zero. Zero. That impossible, beautiful, devastating concept. The number that is also a placeholder. The value that represents the absence of value. On the point on the number line between the positive and the negative, between gain and loss, between having and owing, between presence and void. The number that is in some ways the most philosophically charged of all numbers, because zero challenges us to think about what nothing actually means. And most of us, when we think hard enough about nothing, find it terrifying. But Brahmagupta was not terrified of nothing. He was fascinated by it. Or he was drawn to it the way all great minds are drawn to the hardest, most uncomfortable questions. And instead of looking away, he leaned in. He defined it. He gave it laws. He made it safe. Safe enough that the rest of mathematics could be built on top of it. There is a line I keep coming back to when I think about Brahmagupta. It is not a line from his work. It is a thought that comes from reflecting on his work. And the thought is this: the most important things in the universe are often the things we almost miss. Zero almost missed us. It was there, as a concept, as a philosophical intuition, for centuries before anyone formalized it. But formalizing it, defining it rigorously, giving it arithmetic properties, making it a true mathematical citizen, that required someone special. When that required someone who was willing to do the hardest intellectual work on the planet, to take something that everyone sees and no one understands, and to explain it. Brahmagupta was that person. He was the explainer of nothing. He was the definer of the void. He was the man who gave us zero, and in giving us zero, gave us everything. Now let us talk about legacy, because the legacy of Brahmagupta is both magnificent and heartbreaking in equal measure. It is magnificent because the reach of his ideas is almost impossible to overstate. Every time you look at a digital display, you are looking at a system built on zeros and ones. A binary system in which zero is not just present, but essential. Every time you write the number 100 or 1,000 or 1,000,000, you are using a place value system in which zero serves as a positional marker, a system that Brahmagupta's work helped codify and transmit. Every time a computer performs a calculation, every time a GPS satellite triangulates your position, every time an algorithm predicts what you want to watch or read or buy, zero is there. Brahmagupta is there, woven into the fabric of the modern world, invisible and indispensable. It is heartbreaking because most people have never heard of him. If you walked out onto a busy street in any city in the world and asked people who invented zero, the answers you would get would be confused, scattered, uncertain. Some people might say the Babylonians. Some might say the Mayans. Some might say it was always there, that it was not invented. And almost none of them, almost none, would say Brahmagupta. Almost none would say an Indian mathematician born in Rajasthan in 598 CE, who at the age of 30 wrote a book that changed the world. That invisibility is a kind of injustice, not a deliberate injustice, not the result of malice, but a quiet, an accumulated injustice born of centuries of unequal historical documentation, of the tendency to tell the story of human achievement through a narrow cultural lens, of the simple fact that the history of mathematics as it was taught in European schools for centuries began with the Greeks and jumped to the Renaissance, skipping over centuries of extraordinary intellectual achievement in India, in the Islamic world, in China, in sub-Saharan Africa, in Mesoamerica. Brahmagupta deserves better than invisibility. He deserves to be spoken of in the same breath as Pythagoras, Euclid, Archimedes, Newton, Leibniz, Euler. Because his contribution is of that magnitude. It is of that historical weight. He did not just discover a new theorem or prove a new conjecture. He redefined what a number could be. He expanded the universe of mathematics at a fundamental level. He gave the number system a new dimension. the dimension of nothing. And here is something I want you to sit with as we approach the end of the story. Something personal. Something that I think speaks to the deepest meaning of what Brahmagupta did. Zero is not just a mathematical idea. Zero is a statement about the human condition. Zero says, there exists a state of perfect balance, a point at which you have neither gained nor lost, neither advanced nor retreated, neither won nor surrendered. A point that is not negative and not positive, not debt and not fortune, not beginning and not end. Zero is the still point of the turning world. Zero is the breath between heartbeats. Zero is the silence between words. And without that silence, words themselves would be incomprehensible. When Brahmagupta defined zero, he was not just doing mathematics. He was, in a very profound sense, articulating something about existence. He was saying, nothing is not the absence of meaning. Nothing is a state, a real, definable, a mathematically rigorous state. And that idea, that nothing is something, is one of the most radical and liberating ideas in the history of human thought. Think about what it means for your own life. Think about the times when you feel like you're at zero, when you have lost something, when you have failed, when you are standing at the bottom with nothing to show for the climb. Brahmagupta would tell you, zero is not the end. Zero is the reference point. Here, zero is the platform from which all positive movement begins. You cannot go up without knowing where the ground is, and zero is the ground. There is a reason that in so many spiritual traditions, the concept of emptiness is not a symbol of hopelessness, but of pure potential. In Buddhist philosophy, shunyata, the very Sanskrit root of zero, is the state of boundless possibility. The void is not where things die, the void is where things begin. Brahmagupta understood this not as a mystic, but as a mathematician. He understood it through the rigor of numbers and the precision of logic. And in doing so, he accomplished something that almost no one ever accomplishes. He built a bridge between the spiritual and the scientific, between the philosophical and the practical, between the inner world of contemplation and the outer world of calculation. That is the man. That is Brahmagupta, a man of Rajasthan, a man of the 7th century, a man of verse and numbers and stars and silence, a man who changed the world not with an army, not with a throne, not with wealth, but with a stylus and a thought and the courage to write down what everyone else had overlooked. Now, I promised you something. I promised you at the beginning of this story that I had saved something remarkable for the end. A striking detail, a fact about Brahmagupta that almost no one talks about, that most people do not know, and that once you hear it, will stay with you. Here it is. Hunter Brahmagupta made one enormous, significant mistake. And that mistake is, in its own strange way, as profound as his greatest triumph. When Brahmagupta laid out the rules of arithmetic with zero, he addressed, as we have discussed, addition, subtraction, multiplication. But then he did something that even the most careful, rigorous mathematical minds do sometimes. He attempted to define division by zero, and he got it wrong. He wrote that 0 divided by 0 equals 0. So that statement, 0 divided by 0 equals 0, is incorrect. It is what mathematicians call indeterminate. Division by 0 is, in fact, undefined. One of the great unsolvable edge cases of arithmetic, the mathematical equivalent of an abyss. Even today, in the 21st century, the rules that govern digital computing include specific instructions for what to do when a program attempts to divide by 0. Stop, throw an error, because this is not a calculation that can be completed. If your calculator has ever shown you the word error or displayed the symbol for infinity when you tried to divide by 0, it is because, indirectly through the long chain of mathematical history, it is grappling with the same problem that Brahmagupta grappled with in 628 CE. And here is the extraordinary, breathtaking, almost poetic thing about that error. The man who defined 0, who gave 0 its laws, who made 0 a number, was defeated in the end by 0 itself, when he got most of it right, brilliantly, world-changingly right. But at the very last boundary, where 0 meets itself in division, he found the one edge of the void that he could not tame. It would take another Indian mathematician, the 12th century genius Bhaskara II, to grapple more carefully with the problem of dividing by zero, though even Bhaskara's resolution was not quite complete by modern standards. The full mathematical treatment of division by zero, including the formal concept of limits and the notion of undefined quantities, would not arrive until the development of calculus in the 17th century and the rigorous formalization of analysis in the 18th and 19th centuries. So this is what I want you to take away. This is the thing that keeps me awake at night when I think about Brahmagupta. The man who gave the world zero was ultimately, profoundly, humanly undone by zero, by the one operation that zero will not permit. He opened the door to the void, walked through it with more courage and clarity than anyone before him, defined almost everything there was to define, and then, at the very last threshold, the void looked back. Is that not, in some sense, the story of all great human endeavor? We push as far as we can. We illuminate as much of the darkness as our minds will allow. And then we reach the edge of what can be known, what's the edge of what can be defined, the edge of what can be tamed. And we stand there looking into it, not defeated, but humbled, not broken, but incomplete. And the work we leave behind, incomplete and magnificent, becomes the foundation on which the next great mind builds. Brahmagupta built the foundation, Bhaskara II came and built on it, Newton and Leibniz came and built on that, Euler and Gauss and Cauchy and Weierstrass and Cantor and Gödel came and built on all of it. And you living in the 21st century, carrying a phone in your pocket that contains more computing power than all of the computers that guided humanity to the moon, you are the beneficiary of a chain of intellectual inheritance that began with a 30-year-old man in Rajasthan who wrote a book in Sanskrit verse and changed the world. His name was Brahmagupta, and the next time you press the zero on your keyboard, the next time you see the number zero in a calculation, the next time you think about what nothing means, remember him. Remember that nothing was once undefined, and it took one human being, one extraordinary, brilliant, courageous, imperfect human being to define it. That is the story of Brahmagupta. That is the story of zero. And that is the story of what it means to be human. To look into the void, to name it, to give it rules, and to hand it forward to a world that is not yet ready to understand what you have done. Thank you for watching. Thank you for staying until the end. Thank you for caring about the stories behind the numbers, because these stories matter. These people matter. And their legacies, often invisible, often unsung, always world-altering, deserve to be known. If this story moved you, if it changed the way you think about zero, about mathematics, about the unnamed giants of human history, then please do 3 things right now. First, subscribe to Numbers and Narratives by Bless Wright if you have not already, because this channel exists to tell exactly these kinds of stories. Second, share this video. Share it with someone who loves history, someone who loves mathematics, someone who loves the stories behind the things we take for granted every day. Because Brahmagupta deserves to be known. Third, leave me a comment below. Tell me what part of this story hits you the hardest. Tell me what you are going to think about the next time you see a zero. I am reading every single one. Until next time, keep counting, keep questioning, keep marveling at the numbers and the narratives that build our world. This has been Numbers and Narratives by Bless Wright, and I will see you in the next story.